Welcome back, chemists. In this video, we'll be focusing on something called isomers and nomenclature of alkenes and alkynes. After today, you should be able to draw structural isomers for a given molecule and name alkenes and alkynes. Isomers are compounds that have identical chemical composition but different structures. We will be focusing on structural isomers, which have the same chemical formula but different atom-to-atom connectivity, and therefore they have different properties. For example, C4H10. You can write C4H10 like this as a straight chain, which we call butane or N-butane, N meaning normal. Or you could write it like this, where it would be 2-methylpropane. Both of these are isomers of butane because they have the same chemical formula but different connectivity. Alkenes are hydrocarbons with one or more double bonds. The general formula is CH2N. You may recognize this from the cycloalkane formula. It is identical to that. To name an alkene, you have to use the parent ending ENE. If there's more than one double bond is present, you have to use the ending diene, triene, and so on. To select the parent chain, select the longest carbon chain just like usual that includes the carbons of the double bond. Number the chain so that the atoms that have the double bond have the lowest possible numbers. For example, this again represents a line angle formula, and at each end you picture having two carbon atoms and the hydrogens are implied. Since there are two carbon atoms and this is a double bond, this is called ethene. For something like this, again, you're going to want to identify the longest carbon chain and number it so that the double bonds have the lowest numbers. So I'm going to start my numbering on the left-hand side. And so right away I can see that there are 6 carbons. So hex is the prefix. And this is going to be hexadiene. We have to include the di because there are 2 double bonds. We also have to indicate the location of those double bonds by saying that we have double bonds at 1 and 3. Also notice, to add another layer of complexity, we do have a methyl group at carbon 4, so that's a substituent. We do need to indicate that. So check out this name. So we've got the 4-methyl, accounting for the fact that we have, again, a substituent at carbon number 4. And then we have the 1 and the 3, which indicates the location of those double bonds. Again, we call it hexa because there's 6 carbons in the parent chain, and then di, meaning 2 double bonds, and then ene for the fact that it's an alkene. So if you need to, pause the video and really focus on this question because it includes a lot of information that you're going to be able to have to do. Let's move into alkynes. So alkynes are hydrocarbons with one or more triple bonds. The general formula is CnH2n minus 2. This is named the same way as alkenes, but the parent chain has the ending -ine or YNE. For example, in this case, notice there's one triple bond all the way at the end. If we were to number this chain, we would expect that to have priority. But since there are, in this case, 5 carbons, this is going to be pentyne, right? So you can call it 1-pentyne or just pentyne because pentyne would indicate that the 1 is implied. It's on carbon number 1. In this example, we have a total of 9 carbon atoms, and notice I numbered it again so that those triple bonds have the lowest possible numbers. And so this is going to be called 3,5-nonadiene. Okay, that sounds really weird, but yes, so it's nona for the fact that there are 9 carbons in the parent chain, di for the fact that there are 2 triple bonds, and then ine for the fact that this is a triple bond alkyne. let's practice actually drawing some structures. So we'll do 2-pentene. So in this case, pentene is again something that I focus on. So I would be drawing something that looks like this, where on carbon number 2, I have the double bond because pentene indicates it's an alkene. For 2-methyl-1-butane, so what I want to do here is again draw the fact that it's butene with 4 carbon atoms in the parent chain, and then the double bond indicates that it's in position 1, and then I need to make sure that I have a methyl group on carbon 2. So that's what this would look like. So notice I've got carbon number 1 has the double bond, on carbon number 2 I have the methyl group, and then there's 4 carbons total in the parent chain. All right, so we just finished naming alkenes and alkynes and talking about isomers. I hope this video was helpful. Make sure you ask your teachers any questions that you have, and good luck working on worksheet 4.